We're going to go through and an example so that you can see how to do a scatter plot on Desmos.com, as well as to figure out what the equation is that models the data that we're talking about. So I'm going to go here where it says add item, and then I'm going to select table. It automatically gives us some values for x, and then we populate the y column. You can change the x values by simply clicking on them and changing them, or you can do a bulk delete. I'm just going to leave them there for now for simplicity's sake. So I'm going to put some numbers in that are sort of random. So I have the value 3, I'm going to do the value 8.5, 26, 83, 245. So I went down, then I'm going to put in 722 for a value of 6 right here. So those are the data points that I have. You can't really see them all right now because of the scale that's chosen, so I want to change the scale. To do that, you click on the graph settings, which is the little wrench in the top right-hand corner. So when I do that, I'm actually going to change the x-axis so that I'm only over at -2. I don't really need a ton of values for the x-axis. Now the y-axis, I noticed that my value really only goes down to, I'm going to do, let's say, -2 as my lowest, but I need to get all the way up to 722, so I'm going to put in 750. And actually maybe here I'm going to do -100 just so we have some contrast and we can see. So I've entered that in. You can see all the points now, so now I'm going to click out of there. When we look at this data, it very much looks like it is exponential, the type of data that we've been looking at. So now I want to figure out what the equation is. So I'm going to go back up to add item. I'm going to select fx expression. Now I'm going to tell the program what type of equation model I'd like to use. So in order to do that, we're going to select letter Y, 1. You need to use the tilde, which in my computer is in the top left-hand corner above my tab sign, so I have to use Shift to access it. And then because it's exponential, I'm going to say I want b to the power of. So to do the power of, you do Shift and the number 6, and it gives you the hat. It kind of looks like a hat. And I'm going to say x, because I'm trying to figure out how x and y are changing together, and x1. Once I did that, you'll notice I put a curve in, and that curve is the model that we have. So for this particular equation, it's telling me that there's very good agreement. So the r squared value, the closer this number right here is to 1, that means the more accurate your curve of best fit is. Here, the parameters equal 3. That's telling me that the base is 3. So if I go back to add another item, expression, and I were to graph y equals 3 to the power of x, you'll notice it gives me the exact same line. So this is how you can do a regression. This will work for any equation. If I were to say, oh, maybe this is a parabola, let me do y1 is approximately ax1 squared plus bx plus c. So if I look at that, whoops, it's not going to recognize it because of the x, it doesn't have a 1 with it. When we look at that residual, you can see that curve, that red curve that I have there, isn't really going through any of my data points very well. Over, when it's going upwards, it kind of maybe matches it a little bit, but it's not a very good fit compared to the exponential, so I'm going to get rid of that. So that's how you can do a regression to figure out what the actual equation is.